Well, my friends, here's the painting behind me. Self-fabricating crystalline. Oil on canvas. 99 centimeters by 99 centimeters. If you're interested in this painting, you're interested in more details, or you would like to know the price, you're welcome to contact me on Instagram, on my portfolio there with a direct message. At the moment, I've still got to put one more layer of paint on it and then let that dry, but it's pretty much done by now. There's not going to be any other changes. And to crown it all, my friends, I can tell you that I've got something legitimate here. I went through a bit of a wavy time because I was trying to analyze with a deep search with 3i Atlas, and also I'd gotten some feedback from people on Medium who were very skeptic about my process, and quite a few people. So when a few people start giving feedback like that, people that have had experience extracting data from star maps, all pretty much the same kind of skepticism, then it's time to take notes. So what I did was I checked out some YouTube videos on people that actually do photography, astrophotography, and how they work with the layers and how they extract the data. And all I can say to you at this point in time, what they do is what I do. And the thing is, one of my big tests was that what I'm extracting, the images, the type of, what I call the blueprint design, is basically a consistent image that is taken from different sources. That's very important. It's not taken from the same software. It's taken from different telescopes, and I haven't applied a consistent method of extracting that information. I apply a variation of that method. And then, of course, the background, the main technique, I'd say, and I'd say 50% of that technique relies on an intuitive perception, which of course is going to be slated by science and pretty much most astrophotographers. But that's fine, because indigenous rock painting has always been slated by science. And I've got a little bit of a story to tell you about that a little bit later. But my friends, if you haven't already, subscribe, like, and share. Because when you like this video, you enable other people to see it. So now, the title, Self-Fabricating Crystalline. What do I mean by that? Well, I'm going to give you a little bit of a background of how I arrived at that. From late August already, I started to notice that 3i Atlas was giving off this gas. Okay, here's an image of it here. And inside those gas plumes, which was in the direction of the sun, I noticed that there were artifacts forming inside, shapes were forming inside that gas. And then I came across this science, this plasma science, where what happens a lot with comets is that the chemistry of the comet interacts with space plasma, and the ionization, that process is called ionization. The result is a crystal artifact that appears, but in most cases disappears the closer the object comes to the sun. With 3i Atlas, that did not happen. So later on, when I'd observed that this wasn't happening, when it was coming close to the sun, I knew that there was something else about 3i Atlas. But I only came across the term from my current hypothesis is based on this term of self-fabricating crystalline. So the crystalline part is that formation that I've just mentioned to you now. The self-fabricating part is what I'm going to explain to you next. European Space Agency, ExoMars TGO. That camera aboard that spaceship from Mars at a distance of 30 million kilometers took a series of shots in a period of time, stitched them together and made a GIF. Now, most people that see that GIF, and scientists themselves, discard it just as a little tip, like a little bit of light. But there are some, if you zoom in, you can see, you see the movement because it's a GIF, right? It's stitched up. But the thing is that you get an idea of this object moving in space. But it's got an unusual shape to it. Now, later on, even now, fast forward, January, if you look at Ray's photography, he shot a beautiful GIF. He's put together a beautiful GIF of 3i Atlas, where you see a very similar kind of action happening around the nucleus and the coma as the object moves. You get a similar kind of impression in the European Space Agency, except that the European Space Agency one was pre-perihelion. So it had a plus, of course, it's a different, it's a very high resolution camera, but that camera is not meant for shooting objects. So you're not going to get the definition that you want. However, in astrophotographic analysis, you can actually play around with the shadows and expose what the darkness is hiding, basically, because it just, the shadows have just been dimmed like that so that it all concentrated on that object. And that's the same what you see in the GIF. But if you play the shadows, you can actually start to see there's other stuff around there. And that's how I started to access that GIF. But not just that, with the GIF itself, I saw that there was a tremendous amount of information inside it. So what I decided to do was keep it completely spontaneous, because that's also part of my art making process. And that's another thing about why I've also done the painting, because, as a fine artist, I also have a theme that I work along. And my theme is about extracting data, the undercover data that you don't see, the skeleton, the personality, the energy underneath a situation or an object. That's what I'm interested in. I'm interested in what makes it look like the way it does. And that's what I'm applying to 3i Atlas. Now, how I do that in my paintings when I make a painting is primarily intuitive. Okay, I get a sense of what to do and then I apply it. I don't think about what I'm going to do. I get a sense. I'm always following that sense. It has got nothing to do with my mind or my thinking process, so to speak. And that's what I do with 3i Atlas, you see, when I'm extracting that data. So just to get the images onto my laptop, I decided to go spontaneous with that GIF. And so I let it run. And as it ran, I just took screenshots. Okay. And then I analyzed those screenshots. And I extracted a number of objects. Here they all are in a format together over here. But the most interesting of them all was the first image, which was the halo spread across like that. Now, if I look at that, I see the nucleus. It's very dominant. And then around that, you see all these artifacts. Okay? And then you see this horizontal line, very definite horizontal line, a definite geometry over there. And that horizontal line I later analyzed to be the gas plumes that extend off the nucleus. Now, you can see that it's a tight knit of artifacts. And all around it is this arrangement, this geometry of other artifacts. So what I did was I zoomed into those artifacts and I went to the smallest part and then analyzed how, if there was any repetition that I could pick up in all the other objects. And in a number of areas that I analyzed, I found what I call a basic shape. So I called that a particle, and then I called it a module. And the reason why I called it a module was, to me, it looked like something that fitted into something else. Okay, it made up one module, 2 modules, 3 modules makes up that shape. So, but I think scientifically one would just call it a particle, okay, or a crystal formation, basically a chemical formation. So that's what I was I extracted, and then once I had got an understanding that what I'm dealing with here is one particle that makes up all these artifacts, I could then go into the different blueprints or shapes of the atlas itself that I extracted until that point in time, and I could analyze the surface to a certain degree. And then I started to notice that that particle would cover the entire surface. But not just that. In one particular telescope footage, I could see, which was based on a Hubble footage from the same period. Okay, it was an amateur footage and a big telescope footage that showed the same data during the same period. They could have even been shot at pretty much the same time. I don't know exactly when that Hubble image was shot. I just know that it is a Hubble image. Now, what's also interesting is that with that Hubble image, it was just a matter of cutting it out, because there was very little work I had to do on it. I changed it to black and white because I know that's its original, pretty much its original shot, because they color it afterwards. Now, all I needed to do was cut it out. And there are some points where I had to really use discernment, but also I had to play around with the light and shadow to get an idea of the difference between the body, okay, and space. And that's always a dangerous point. However, with that particular image, there were only small areas where that happened, very few areas. The greater part was very visible to me, and so I could extract that image. That's a very good image that I've got, and that's from Hubble. Now, when I got the amateur footage and I extracted that, I didn't yet know whether that was linked to the Hubble image, but only found out later through my analysis. But this amateur footage, I was able to then go really into it, and then that's where I started to see that that module, the particle, what made up the body of the atlas. So, coming back to the European Space Agency, I noticed, even before that, in round about the 7th of September, I already knew, before scientists had confirmed it, I knew that the atlas was spinning and rotating, according to my analysis. Because every time, every day or second, third day that I got footage from an amateur telescope, the atlas was sitting in a different angle. It wasn't just flying that same shape the whole time. So that's why I thought it was tumbling. And then when two scientists confirmed that was great. And they also confirmed that it was spinning. So now I had that information together. So in the European Space Agency image, every time it tumbled. Now, you can't see it tumbling, right? I'm just saying that I already knew, I had been confirmed, science had already confirmed that the object tumbles and spins. And if you lighten up the area around the atlas on the European Space Agency images, you can see signs of the spin. Okay, here's one of those signs of the spin. Now, so the object's tumbling. But every screenshot that I took, the object had changed shape. And what I call the blueprint design, which is primarily based on the shape of the nucleus, the outside shape. There's a design around that nucleus that consistently shows up in every single image, right throughout. That design was there even from the first images that I got, that first GIF that came from the Gemini Observatory. And that was the first ball of light. I also took screenshots of those, and I extracted two of them and came up with two different objects. You know, only later on I realized why I saw two different objects. It's because the object is also changing shape. You see, it does change shape. But how can something so big change shape so quickly?